Okay, good afternoon. We are from NTT Group, a Japanese telecommunication company, just like British Telecom of this country. We are participating in this LINX meeting for the first time to introduce our optical switches. Please think about a situation where you come across a sudden network outage, or please think about a situation where you need to restructure a large and complicated system without interrupting network operation. These optical switches will surely provide the ultimate solution for such urgent problems. We have a variety of optical switches shown here, 1x2, 2x4, and larger systems. And the features and advantages. Firstly, this is automated switching with online power monitoring, which leads to the great improvement in network outage restoration time. According to Japanese IX, the downtime was drastically decreased to 15 seconds. It is only 0.000047% of total operation time. Secondly, the reliability of the optical switches are much higher than that of other network equipment. The MTBF is more than 1,000 years. Thirdly, because there is no optical to electrical conversion in optical switches, there is no disconnection of the session even during electric outage. The optical signal itself can be transmitted during electric outage. Let me talk about application example of optical actual network. IX, ISPs, and data centers operating in the clouds, making use of optical switch for communication path redundancy, for bypassing a node in disaster, and for N+1 redundant solution. And the first example. Site 1 and Site 2 are connected with actual route A, and in the case that route A should be switched to backup route B, the automatic switching is made within 10 milliseconds. Owing to these photodetectors, the switching is made with automatic confirmation that backup route B can work normally. The second example, in metro ring network where optical signals are transmitted through many nodes, communication is disrupted if only one of the nodes gets into disaster and electric outage. Making use of optical switch as a bypass switch, such disruption is avoided easily. In the case of sudden electric outage, the switching is automatically made so that the signal can bypass the node, because the optical switch itself is run by an internal battery. The third example, the so-called N+1 solution has recently been very important in constructing 100 gigabit communication system because network equipment for high-speed DWDM is still very expensive. To make a large system with N lines redundant, the number of expensive equipment needs to be doubled. But if N+1 solution is available where one backup line is shared by all active lines, the big cost reduction will be realized. The N+1 switching system has already been designed for Japanese telecommunication carrier and will be in operation soon. We are exhibiting two kinds of switches of NSW and CSW at our booth outside of the hall, and pleased to make the demonstration for you. Please visit our booth to actually observe them. Thank you for your kind attention.
Thank you.